floor is yours, Ken.
Ready? Can everybody?
Yep.
Can everybody hear me okay?
Yes.
Good, good. Let's see, go to share screen, I guess. I'm not sure how to do this. Oh, okay. We're here already. Can everybody see that screen?
No, you're not sharing your screen yet.
Okay.
If you go back to the Zoom and go to share screen.
Okay. Oh, okay.
There we go.
Great. Okay, so we're going to talk about my usual favorite subject is urban streams. Although I love the ones with a million bugs and fish in them. You know, urban streams are very important to me. I'm currently working on a paper, actually, and a lot of this is going to be in the paper. But I think people have ignored, at best, ignored urban streams. And I think they're a real resource. Hopefully that will come out. In addition to just how hard it is to actually restore urban streams. Okay. So these are the points I'm going to try to cover. This is going to be fairly informal. So whenever you have questions or want to make a comment, just use the chat. So we're going to start with my usual refrain. Okay. Okay. Urban streams are not dead, which is what people used to say all the time. But from rummaging around in urban streams a lot of years, that statement is not really so. Sometimes urban streams can look pretty bad, but they have their own flora and fauna, and they are very much, in my mind, an ecosystem. I think, you know, where the folks were coming from when they said urban streams are dead is that they would always compare them to some idyllic habitat, right? Like Baseman Run or Pond Branch or something like that. And when you look at them on that scale, that's a pretty tough comparison. So that they don't fare as well, but I have a feeling that we can do a lot to improve them. Okay. So this is my slide that shows actually the topic of a very famous paper in aquatic ecology, urban aquatic ecology. And there were always so many things affecting urban streams that they just called it the urban stream syndrome, because there was so much going on between the pollutant, sewage leaking, runoff with all the urban pollutants from the streets, and so many more things. But I think that we can deal with the urban stream syndrome. And just to kind of, I can't see my own screen here. Oh, guess not. Okay, so, whoops. To give you a kind of a look at what I consider worthwhile urban streams. The one on the left is actually, you might notice it, you might recognize it. It's down by the aquarium. So even though that's technically the harbor, I count it as part of a stream because I look at streams, all streams really, as a continuum from the headwaters down to the estuaries and even the oceans. And the slide there is kind of a neat one. I love the floating wetlands there. So that's an example of a restoration technique that's really catching on, and people love it. There's a lot of life there. At one time, they had a camera that looked at the bottom of that floating wetland, and you could see all kinds of critters. The large slide at the top, large picture at the top, is Stony Run. So that was somebody's favorite stream. And I think, especially since restoration was done on parts of the stream, it is a very cozy place, and it is very natural looking. And we still might not have all the critters we'd like, but it's a great place to go in terms of aesthetics. There are lots of things like that, like those stepping stones. They're actually stepping stones to get you across the stream, and it's very beautiful. The other thing I want to make sure I cover is in the lower left. So a lot of people don't realize that there is, when you see a stream, there's actually two streams. There's one stream underneath the one that you can see. And it's actually a very important stream. Scientists call it the Hyporheic. So it sits between the flowing water in the stream and the very, very almost still groundwater. So it's kind of an in-between state, but there's a lot that lives down there. And in effect, if you're going to restore, say, Stony Run, you would have to restore the Hyporheic too, because a lot of critters use that underground, those underground tunnels and holes and porosity as refugia, is what ecologists call it. So it's cooler down there. You can't get eaten, right? So if you're a baby mayfly, it's a good place to be, right? As long as you watch out for those other critters. So that's kind of an important, and the two are connected in that way. The other reason that Hyporheic or the Hyporheic is important to us is there's a lot that goes on down there in terms of biogeochemistry, which in this case, and in a lot of cases, we're talking about processing pollutants, taking nitrogen out of the water, all sorts of things. So we'll talk a little more about that later. And the ever-present snails. So there's a lot of diversity in streams. You know, I am not just an invertebrate guy, but you know, my favorite topic are the freshwater aquatic insects. So fascinating, and there's so many different kinds, and they all make their livings, so to speak, in different ways. So you can just get an idea of the diversity just looking at these pictures. And you know, a good number of these could be found in an urban stream. Some of them can't cut it there, but maybe restoration will change that. So I mentioned microbes before in the Hyporheic, and that's a very, this process of denitrification is extremely important to a lot of aquatic ecologists and engineers, because it's like a little treatment plant in terms of removing nitrogen. A lot goes on in the soil and in that Hyporheic zone that is actually pretty good. So in this case, it's taking care of a nitrate nitrogen, which is a serious pollutant.
Hey, Ken,
Yes,
could you go back to the previous slide? Heidi wanted to know what is D? It looks
bee.
like something
Oh,
D, the
those,
letter D is in dog. Mhm.
yeah, those are stoneflies. In this case, I believe shredders, which are an aquatic insect that actually tears fallen leaves into little pieces, which starts a whole cascade of trophic processes that go downstream and keep
The
it
D, the D is
alive.
in dog. The D is in dog are the stoneflies?
Oh, no, I'm looking at B as in boy.
No,
Sorry.
D is in dog.
D is a really interesting one. You don't like them when the adult form bites you, but these are black fly larvae, right? And they're really kind of cute. They sit on a rock just like they look like they're doing, and they have fans on the tops of their heads, and they actually use those to catch suspended organic matter in the current. And they will actually get to the top of the rock and they will actually fight over the best spots. So one will actually get in front of someone else's fan and there'll be a little bit of an fight. So any
And
other?
one more, yeah, Edward wanted to know what's the difference between the benthic zone and the hyporheic zone.
The benthic zone, if you've ever gone out to sample bugs, you're disturbing the benthic zone. So it's just the very top, and mostly, it's kind of like a cob, ideally, although it could be muddy or sandy. But yeah, that's the top layer, and right below that is the hyporheic zone. And then if you follow that to the bottom of the hyporheic zone, that's groundwater.
Okay, thank you. That's it right now.
Okay, good. This is just an example of that hyporheic zone again, and how the flow goes in between all these spaces. And there are actually biofilms that do the processing. Actually, there are biofilms everywhere. Hopefully, we'll get a chance to talk about that. But these are like little sewage treatment plants because of that. So slime is good unless you're fishing and you slip on it. As I just mentioned, there are biofilms everywhere now. That's how researchers anyway think of them. So there's the traditional one at the bottom of the stream that you slip on when you're fishing, but also there are biofilms around the soil particles. There are biofilms on leaves. That's the phylosphere that you might see there. All this is going on, and these are really a collection of different kinds of organisms, from bacteria and fungi down to very small invertebrates and protozoa. So it's really kind of an interesting thing. I guess you could say that the landscape is alive in so many different ways, mostly in ways you cannot see. Okay. Talking about, I mentioned before some insects help to break up the leaf litter, which is food to a lot of insects and other organisms. And you actually can get, like in that top center slide, in the fall, you get an accumulation of leaves in little leaf packs. And if you if you go and put those in a tray, you'll see all kinds of aquatic insects walk out, because that's where they stay. And once again, it's a team effort. The bacteria and the fungi go at it, breaking down the leaves, and the aquatic insects go after, in a lot of cases, they eat the bacteria and fungal biofilms. So in this way, the leaves get chopped up into little pieces, which go downstream For example, the really small pieces would go downstream and maybe be caught by one of those black fly larvae in their fans. So there's so much going on there. So many, there's food flying everywhere, so to speak. But these are just a bunch of insects that kind of help with that process, and they call them shredders. Okay, so real quickly, why do we care? If people felt like urban streams were dead a long time ago, why do we care about restoring them? Or even what I'm trying to do is actually, how do we figure out how to build those ecosystems so they're better ecosystems? And this could be a talk in and of itself, but you could think of so many more things. For one thing, the way I look at it, urban streams are our neighbors, right? And I may be weird, but I've always loved walking next to streams. It was actually my first job with the city. And I pretty much have walked every stream in the city and a whole lot of the county streams. And it was kind of curious to me at the time because I was working on a what they call an exfiltration project. So basically exfiltration is what they call it when the sewer pipes that often are in the stream or next to it, they leak sewage, which no one wants, right? And I was always amazed because engineering group, and the engineers never could understand why we were worried about a little sewage leaking out, right? And I always told that story because it speaks to where this idea urban streams are dead came from. Because to the engineers, the most important part was keeping the treatment plants going, right? So if you lose a little water, who cares? I mean, lose a little sewage, who cares? They cared a lot when water went the other way, when stream water leaked into the sewers, because that took away capacity for carrying the sewage to the treatment plants. But there's a lot of recreation. More and more and more people are very interested in nature, right? Thank God. It's a water quality thing. Save Our Streams used to go out and bugs to raise. Are they healthy or are they in trouble? And I want to underscore this other idea that downstream counts, because there is this stream continuum. Headwater streams, the ones at the very tips of the streams, they do certain things really well, but as you move down and the streams get bigger and bigger and bigger, they all have kind of a different ecology. They're built in different ways. And a key feature that I think is still lost on a lot of people is that in a lot of cases, they reach an estuary or a coastline, right? And just to give you a hint how important that is, unfortunately, COVID is an example, right? So you may know that they figured out that you could monitor the sewer sheds and tell when COVID was coming, because it's released into the urine and feces, right? And it was a great, I think they had a name for it. They even called it wastewater-based epidemiology or something like that. Works like a charm. But the problem is too, they're also finding COVID in streams and other waters, including groundwater, right? And it may not be enough to infect people unless you're at the treatment plant yourself, but it's only one thing of so many different synthetic chemicals and now materials. It's astounding. this was a topic with ecologists 10 years ago. They said, we got to study these strange pharmaceuticals that make it into the stream from the sewage and this and that and the other thing. And instead of getting better, it's gotten a whole lot worse. You're probably familiar with plastics, right? Microplastics. And now they have nanoplastics. And apparently they make a whole lot of nanomaterials now. So one of the pollutants that you can't see without a good microscope are a certain kind of nanoplastics that are manufactured to make clothing. So literally these things are released when you wash the clothes. And they're not terribly good for the environment. The problem is they're making new stuff all the time. So a lot of work to be done there. And I guess there's the picture on the right is Baseman Run. And the mayfly down there, if you notice, has a slightly different anatomy. And that's just to remind me to say the fishermen love streams too, even urban ones, because there's that little hook coming out of its tail end. But if you look at the picture at the top, that straight as an arrow line there, I consider that an urban stream too, because it runs all the time. It's very cool. It's a concrete flume, but nature finds a way. A lot of times I'll find plants growing in the crevasses in the concrete. And of course, the minute you get something going, a whole lot of critters like that. So even that to me is an urban stream. And, kids always like streams, even if it's this one. If you can jump in it and make a big splash, it's good. Another thing that's kind of important is the enormous growth in urban areas. They're really in so many ways taking over the planet. So urban areas are no longer this little piece of nature. They're quite important in terms of area. And people are starting to look back to urban streams and say, well, maybe these should also be areas where you encourage conservation for biodiversity purposes. And I'm going to say this a bunch of times, urban streams are not gutters. That is definitely how they started out. Hence the engineer story that I told, but they really didn't have any. As a child, I played in Herring Run and it was full of sewage. I didn't know that at the time, but they really were considered conduits for getting rid of stuff that people didn't want, including stormwater. And it's really very interesting. I just came across this today, but there are some strong movements to actually give, so far it's rivers, rights. The question has been coming up in the literature, can rivers own themselves? Right. So it's a really interesting concept. I hope it takes off and goes somewhere. But I'll be there trying to get it to be applied to urban streams too, because so many people live they're our neighbors, and we should treat them like parks and refuges, like we do parks. So, and I'm probably, I'm dangerous when I can't see a clock. Probably going too
You're
slow.
fine. Keep going. You're good.
But I found this in a USGS publication, and it really says a lot to me because I've seen this so many times. Urban streams can look really bad, right? And it doesn't have to happen. There's a lot of infrastructure repair and behavioral education, I think, that has to happen. But it's pretty awful looking at this. And I have some pictures. I couldn't locate them quickly enough, but I would take pictures in Carroll Park below Washington Boulevard. So obviously the Winds Falls gets pretty nasty during big runoff events. And down there, it was almost like a crazy kind of artwork, because the whole area had lots of trees, but they all had plastic and paper hanging from them, because that's how high the flood was. And it was just such a surreal stream. But it says, you know, we have to start respecting the streams and paying more attention to those little stencils with the crab on the storm drain inlets and some other things too. So streams are not gutters anymore. The picture on the left is Stony Run. And if you see that rectangle on the left of the picture, kind of rusted out, those were the streams I knew as a kid. And basically the sign says, beware pollution or something to that effect, do not enter, right? And these were on almost every storm drain. On the right is a storm drain in Herring Run, same kind of sign. But that's again was how they looked at these. It didn't seem to bother people that these were so dangerous. And then of course, you may have heard of what are called combined sewers, right? Which is when a city has a sewer system and no storm drain system, because the stormwater runoff runs in the same pipe as the sewage, which produces some pretty nasty situations. And this particular one is the combined sewer outfall in Portland, Maine. So otherwise in a very nice redone harbor area, but this is where sewage was still coming out during storms. So when you're actually thinking about restoring a stream or its watershed or its ecosystem, is my preference, first you have to fix the watershed. And a lot of times this does not happen, even though a lot of money is spent on stream restoration itself, because they're all connected, especially in urban areas. All those pipes take so much of the impervious surfaces in the whole watershed directly to the stream. So you've got to think about the watershed and fix that first, because that's where the horrendous wash off is coming. That's a lot of energy, and that ends up tearing streams apart. So fix the watershed still means fixing old sewage lines. So on the left, that's a picture of a tributary to Herring Run, I think. But if you look in the left side of the picture, you can see a shiny object, and that's a sewage pipe, right? You can't see it the rest of the way because it's encased in concrete. But in this case, that storm drain you see in the upper right-hand corner has sent so much water at such times that it's exposed the sewer pipe. And yes, the kind of grayish color in that pool is sewage. This was right across from the Loch Raven library. That's how I started my career, right? Looking for leaks from sewers. And today we're still missing them. The picture in the center is Mine Bank Run in Cromwell Valley Bridge Park, and it's actually an example of those horrendous flows that have wiped away the bank and exposed a pipe, which I believe is sewage. It could even be a water pipe for all I know. So that is what And that was actually the reason there was a lot of money spent on stream restoration in the park there, right? And unfortunately, the watershed won because it exposed a pipe that wasn't exposed before because of all the restoration. And there are sometimes purposeful releases of sewage. So on the right, the picture that's in Ellicott City on the Patapsco, and that's a sewage overflow structure. So these pipes get overwhelmed and the sewage is left out into the stream. Those are a lot fewer than they used to be, but you still have that happening, along with the picture on the left where, you know, sewer lines actually are leaking. So you got to fix these things. That's all part of fixing the watershed, right? Because there are sewage leaks up in the watershed as well as at the stream. So this is on the left is just showing you, you know, that there are all these gutters, and that's where the water receives its first push. That's where the water in the pipes gets its velocity from to start. The other pictures are from Mine Bank Run. And this was extensively restored. So they improved stream banks to keep them from eroding away. A lot of the work was like that, and a whole lot of other standard stream restoration techniques. Usually these are expensive and done in a big way with heavy equipment in the stream. But in this case, there must have been a humdinger of a storm that came through and did all this damage. Okay, so in the picture at the top, you can see where the bank is bare once again, right? And below it, it's kind of hard to see in the picture, but the stream was the storm runoff was so powerful that it moved these cobbles and a lot of sand too downstream. And what you can't see is that area with the stones represents effectively, if you're in the stream, it looks like a big mound of stones, right? And that just tells you a little bit. The mound actually looked like it was 6 to 8 feet high. Okay, and that tells you something about the power of stormwater runoff. It brought all that from upstream. And the picture on the right is that same breach, showing you what it did in terms of erosion around a culvert that brought a small tributary into the stream. It also shows you how the stream has down cut as a part of all this, this water violence, I'll call it. But you can see how high up the bottom of the culvert is. That was at one time a lot closer to the water line. But that's one of the other things. The streams basically, I like to say they eat themselves alive, right? And of course, all this goes downstream, eventually contaminating the bottom of the stream downstream. So up in the watershed, what do? You do what you're starting to see a lot of. You do stormwater management. Sometimes they call it low impact development. And there are another 15 acronyms that describe this idea of holding back water in the landscape and releasing it more slowly in the pipe that goes to the stream. These can be huge facilities. These can be very small ones in the middle of a parking lot. My favorite kind of stormwater management structure is on the right. Excuse me. And that's what engineers call a treatment train. so much sense because it isn't just one thing. It's three stormwater management facilities in a row. And as you can see, it's built to kind of imitate a stream system, a wetland and a stream flowing through. Unlike some of these others where you can see it's basically just turf. There's just grass in there to cut. And the pictures at the bottom essentially remind me to say, these things aren't free, right? There's a lot of maintenance that goes with them. So at some point, the picture on the lower left shows you essentially have to rip the whole thing out because so much silt and soil and all kinds of things have settled in the basin. Okay, so then you start talking about fixing the stream. And there are many ways this can be done. I'm just going to give you a few. This is, I guess this is the slide I meant to use for Mine Bank Run. But there are a lot of ways to go at fixing the stream. One of the ways is to realize that there are so many buried streams. You can actually daylight those streams. You can uncover them, and that's been done a lot. It's becoming even more and more popular. The slide in the left, the brown lines are essentially streams that have been buried in Baltimore City. We don't have a lot of our stream network left, actually, because of all the development and the paving over. So there's a lot of room to work there. A newer kind of technique that I kind of love is people realize that beavers can do all this work better than we can, right? And they keep repairing the dam. And in the picture there, you can see where this beaver dam, which is the brown shape going across, right? So that creates a pond. It also creates, you can see these in the picture, the stream branches into more than one single channel, which in this area was actually the normal stream appearance, right? Our channels didn't always look like single channels. Way back when, this is what a stream looked like. But so many good things happen, beavers really do fit the description of being an ecosystem engineer. So they not only make these ponds, but they make the water flow through the Hyporheic zone. They move things around. They make the landscape more porous. All kinds of things. So, of course, doing this in urban streams is a little difficult, but they are doing it in certain cases. One day I'm going to find a beaver in the wild. There's so many ways to talk about restoring connectivity, right? That could be a connection in terms of just water, right? So you have wetlands that should be feeding a stream in some way. A lot of times we filled those in, and all sorts of things like that. But I'm going to talk about a slightly different kind of connectivity here. Culverts are kind of the cheap way of avoiding building a bridge, right? So you can kind of see how they work here with the picture at the top and the bottom and on the right. So it actually looks like they're pretty easy to put in, right? Unfortunately, the ones shown in the pictures here put a stop to aquatic organism passage. And people usually think of fish, right? And that's a really interesting restoration technique to knock out dams and to replace culverts like this. Um, and it really is a showstopper. Fish need to get upstream, and even small barriers can cause fish in a stream system to they can even lose genetic diversity, which is not good for the species. The picture on the left is an example of, I think they call it the blackout. So all the lines you see, blue or black, are streams, right? And you can kind of see where the main stream is and where the headwater streams are. Forms of fish and even aquatic insects, they're all colored black. And this is an appreciable part of California. They're colored black because fish can no longer get upstream. So there's just no value. And these are, I think, dams and culverts. But it just shows you how widespread something like this can be. It's a construction technique that people are only starting to realize doesn't have to happen. There are other ways to build these stream crossings. And actually, the slide on the left is from a Forest Service publication. So national forests, there are a lot of around the country. And of course, when you have national forests where there's logging that takes place, you have a lot of stream crossings, or if you prefer, road crossing the stream. And there are all these culverts. And they did this study, and they actually, without considering the fish, they figured out that, if you built these differently, if you spent a little more money, in the long run, it was well worth it. Because eventually a storm comes along that is very powerful. And whenever water comes out of a pipe like this, it swirls on the left and right, right? And that tends to erode away the stream bank. And the culvert eventually fails, right? Also, you can see the picture at the bottom, a plunge pool can form where there's so much erosion that, that's very low and the fish can't get up that distance. It doesn't take much to stop a fish. I didn't realize that, but these culverts were the cheap way to get a road past. And I was trying to get some better pictures of this, but there's something new, and it's called stream simulation, which is a horrible name, but it means that instead of putting a pipe in the side of the hill, you're trying to build something that kind of simulates a natural stream. So you can almost feel like the one in the top picture, especially, that covers the entire width of this small stream. And so normal processes can happen in that kind of a culvert. So the sediment can move, and it's a lot more like a regular part of the stream channel, which is great for the fish and the bugs and a whole lot of other critters too. Hopefully it catches on. One of the things I want to do is go to the city and start to get them to think about things like this. Because I'm sure the city has more culverts than the Forest Service on a per square mile basis. So if we want to restore streams in the city, that may be a good place to start, especially if it's cheaper to not have to maintain them and to replace them too often. Okay, this is the part, it's kind of empty, because although there's a huge amount of money that's spent on stream restoration, it's kind of entertaining that they always want to prove that the restoration was good for the fish or the bugs. But I go back to a famous paper. It was something, the title was something like, you know, the fuzzy logic of restoring streams in the channel, and, you know, in a little piece of the stream at that, and expecting the biology to come around. Because the biology needs a whole lot of things. It needs to actually be connected along that whole watershed, right? Aquatic insects even, they will lay eggs in the water, right? And then hatch, but they also need to be able to fly to distribute themselves. Because obviously, you know, some of them do swim upstream, but most of them don't, at least not very far. And there's also a phenomena called drift, where they just kind of let go and allow themselves to be taken downstream. So they have to have a way of getting redistributed upstream. And of course, barriers make that hard. In this case, it's the lack of a riparian zone, right? Because they will use the vegetation on the sides of the streams to not get to hide, and so not get eaten. And of course, when they fly upstream, if there's a huge culvert that's part of a hillside, that's not very good either. The lights in the city are another problem. But I think another problem, can they get from this watershed to the one right next door? So say if you restore the watershed and the stream in watershed A, but on both sides, the watersheds are shot, and there are very little in the way of aquatic insects. How are they going to find their way to the good stream that's been restored? It's a big question, I think, and I think it has to be answered. I've been pleased, though, I found quite a few papers where people were transplanting aquatic insects to try to get them started in a new place, right? So dispersal is important to any creature. I don't care who you are. If you don't solve that problem, your species doesn't do well. And so, and I've been using old map of Herring Run. Some of you have probably picked up on that, but this is around the turn of the century. And I think I always look at this and think this is what we have to get back to somehow, right? Because that's where the streams were, and, you know, there wasn't a lot of pollution, although, you know, sediment was a problem, but it just reminds me that they're there. They're still flowing. They're flowing in pipes, and they're just waiting to be reborn. One last point. In past talks, I've talked about the Jones Falls, right? So it stunk so much, they just covered it over at one point. And that's why you don't see it for a good chunk of downtown, from about North Avenue, you know, down to not far from the harbor, right? But people are awake, they're waking up to the idea that these streams have functions, and that even if you look past restoring the biology, these streams, when they're restored, are habitat for people. And anything that gets people close to a stream ecosystem of any kind, I think is a good thing. So these are pictures of a very famous stream restoration in Korea, in Seoul. I think I'm going to screw this up, but the stream is Cheonggai-cheong or something like that. And it was a horrible stream, right? It was just like the Jones Falls. There was nothing here but a huge, many lane highway. And this is kind of what they've done with it. It's a a place where people can walk without being run over. It's a lot of the areas under the bridges are actually art museums. And there's so many amenities along here. People really love it, right? And it's certainly better than the highway that was there. So I think I'm running out of time probably, but the picture on
But
the
keep going.
is
Keep
that
going,
okay?
Ken. You're all right. Yep.
Okay. The picture at the upper left shows that Hyporheic zone. Somebody asked about that before. And that flows kind of the same way as the stream does, just slower, right? And sometimes the groundwater flows into that zone and nourishes the stream. But there is that area that's underneath. And what's also cool is if you look at the middle of the picture in that arrow, there's a bend in the stream, and the Hyporheic zone is actually underneath of that. So it's flowing, even though you can't see it. There was a time I visited what is it now? Flat Lake Biological Station. And they had a large alluvial stream with all this gravel. And they took us to a well that was about a quarter mile away from the stream. And they took the cap off the well, and all these stone flies started flying out. So it's a really fast moving aquifer in that case. But the stone flies had adapted to doing most of their life cycle there. So, and I never knew that you would actually be able to do that. I'm used to juveniles and very young critters spending time in the Hyporheicus in the stream, but this was crazy. It just shows you what can be done. And sometimes I wonder if that can be engineered. So on the lower left is a rock, and that may look pretty gunky, but to me, I can see all the caddisflies, some mayflies, and a lot of retreats that the caddisflies built. Those little agglomerations of sediment. The center picture is there just to remind us that part of any restoration has to involve, I think, the adult stage of aquatic insects, because again, they have to, emerge and fly. They stop being aquatic and they start being adult so that they can lay their eggs. And the yellow thing in the picture is called a sticky trap. So it's kind of like fly paper, but any insects that are flying in the stream get stuck to it. And then they take that back to the lab and identify the insects. But it's a reminder that, they need flyways too. So if a species is going to propagate, they need that in addition to good habitat in the stream itself. And the other pictures there are just hydrocycid caddisflies. That was a cute picture. Thank you. I'll take any and all questions as long as there's time.
Thank you, Ken. Can you unshare and we'll come back together?
Mm-hmm.
All right. Hello?
I hear you.
I lost my chat box for some reason.
I can see my chat box.
Okay, hold on. Okay. Oh, all right. I'm unfrozen now. Okay. Thank you so much, Ken. And do we have any questions Again, you can raise your hand and I can call on you, and you can, and I'll let you unmute. We have a couple, let me see, there was one question up here. Mimi was asking, what is the process to daylight a stream that is in pipes or underground? What goes into that?
A lot of engineering. So, and it depends on how deeply the stream is buried. But basically, it's a lot of people are doing it. And I've read a number of books that are really interesting because they talk about these streams that are underneath of urban neighborhoods. And people really do want to know what's down there, what the history is. So I think at the very least, sometimes the stream, the buried stream can no longer carry the water, the stormwater that it needs to, right? For one thing, there's more stormwater than there used to be when it was a stream. So that causes a lot of flooding, and people have figured out that if I take the top off of that stream and engineer the rest of the reach, I can get much better performance just from a flood control point of view. Sometimes there's a stream I have my eye on in Canton, and you know, it's right under the parking lot of the Safeway there. And the city has always had trouble with that underground stream, and there's a substantial base flow there because the conduit is old and it keeps falling in. Well, I'd love it if the next time it falls in, they just rip it all out and put something much more like the Korean stream in, even if it's on a small scale. The nice thing there too, I thought I saw a question about some history. At this same location, apparently there was the first naval shipyard, and it was where the Constellation was built. It shows up in old maps, and now it's under a parking lot. So that's yet another reason maybe to daylight that stream. So, you know, to me, history is super important. I think that a large part of bringing streams to the surface is a good thing because people could start to learn about their neighborhood, most likely before they moved in, but there's still a history there. And it'd be really cool if that history could be uncovered and made available to people.
What Joe asked, what's an example of a healthy urban stream in the area? What would you suggest?
Well, the whole area is urban, so I guess, you know, that's a lot of streams will have lots of bugs. Not sure if you count Basement Run. There are lots of bugs there that are very diverse, but that's protected in a park. Gosh, it's been so long since I did this. There have to be a bunch of streams. Unfortunately, Mine Bank is not one of them. The flows are so horrendous. I don't think much has a chance to get going. Gosh, it's just been so long since I've sampled bugs in streams, and I'd like to get back to that. But I would think if you look for watersheds where the channel looks fairly stable, right, and there's not a lot of erosion, it's very nice if the stream is not down cut, right? So that if you're in the stream, you're looking at the stream banks up there, right? Any stream that has a riparian cover, that's going to keep them cool and hopefully counteract some of the heat in the summer that's going to come off of impervious surfaces. So all I can tell you is generically what to look for. It's so true though, is, you know, the further you get from the Beltway to the north in Baltimore County, at least, the better the stream communities get, for, you know, for obvious reasons.
So are you saying you're judging the health of the stream by the diversity of the macroinvertebrates that are found there?
That's one way. You could do it with fish. Some people do it with midges. Okay, so these are the little bugs that fly up your nose when you're jogging, right? But they're so small. I have actually found their larvae, because they build little retreats on the stones, but I have found their larvae in the bottom of storm drains, where the water is just hellacious. But in hydraulics, there's something called a boundary layer. So when water moves past them, they're so small, they don't feel it. Because right next to the side, the pipe itself, the velocity drops off a lot. So that's where they, as long as they don't stick their little heads up, they are able to withstand a lot of velocity. And I think they would, a number of people have used them as pollutant indicators, just like macroinvertebrates. They're a lot harder to identify though. But I have a feeling they would be a really neat topic for a field study, because they have this other feature. And I've noticed that they build these little tubes, but everything else collects around them, algae, and it gets mixed with sediment, and it creates this whole different kind of biofilm. And a lot of times those don't seem to get scoured as much as I thought they would. So I think, you know, we like to come up with generalities as to, you know, why this stream is lifeless, but I think you have to look at the whole ecosystem to really figure out some things. I think that's what we're going to have to do with urban streams because of the velocity issue. So
well, and speaking of that, Gary wanted to, what do you recommend to plant alongside creeks and streams?
I think anything. You know, you always kind of like native vegetation, but you know, a favorite tree for me are basically riparian trees like willow, which, you know, you can actually plant. Oh, what do they call them? Essentially, they look like little sticks, and you just shove them into the ground, and they grow into this thick vegetation. But willows and what's the other one? Very common riparian tree. Poplars, right? People use those so much. They actually use them because they bring so much water up, right? They are actually part of a lot of bioremediation techniques. So even in a landfill, they have actually done genetic studies, and they'll tailor a genetic variant. I don't like that word anymore. Genetic variant to see which one of the species is going to do the job for whatever it is, the landfill or, you know, whatever. But they're very effective. They suck like crazy, right? So they're very good at moving water, and people have also used them to change groundwater movements with respect to where pollutants are and things like that. But I think the county, Baltimore County, has done a really nice job. These things, they're very cheap to plant, and they grow quickly. And pretty soon you have a pretty thick vegetated area, which provides a lot of habitat for all kinds of insects. And it actually slows the water down a little bit when there is a flood. So yeah, they're pretty popular.
And in the chat, with some really exciting projects that folks are talking about. Gary Mosca is working on the Cadorus Creek corridor, something similar in York City, and that's something that's going to be similar to Korea. Sarah's in Montgomery County, and they're working on what was that one? A Willett Branch in Bethesda. So they're working on a project that they've been working on for 7 years now. And so it looks like there's some real interesting and innovative projects. Folks want to know what you think of the Carroll Creek in downtown Frederick, Maryland.
I'm not familiar with it. Is it a daylighted stream?
I just got off of the mute. Can you hear me? This is Robin Wilson.
Yeah.
So yes, it's a daylighted stream, and I first moved to Frederick about 25 years ago, and most of Carroll Creek at that time was an underground stream. And I remember about 25 years ago going to a display that they had at the mayor's in the courthouse there downtown, where they were talking about how they were going to do this. At the time, my husband was he's still a professor at Hood College. And so it was very, very interesting. And they did the project and they daylighted the stream. And I think it's spectacular. And I don't know how well it's met the ecological goals, but it's become a center for humans to go and just really enjoy it. And I think it's a huge success. So I would recommend looking into that and see what the biologists think.
Yeah, I'll have to. That's a good excuse to go back there.
Oh, yes.
I went there a long time ago, and I remember eating at an Ethiopian restaurant, which was an experience in and of itself. They don't give you silverware.
Oh, you're supposed to eat with your hands, and the special the grain that they have, a special grain that you can. I know it well because my daughter has celiac disease and she can eat it because it has no gluten. So I highly recommend Frederick. I also just wanted to mention I'm in Baltimore County around Cockeysville, and the Beavers have really taken over. Routinely, we see a family that has kits every year. We play music along the NCR trail. There's a little place where there's a bridge crossing near Paper Mill, and there's always a beaver dam there, and every year there's the baby beavers, and they come out and watch us play music, and it's very easy for people to photograph them. I also have them in Cockeysville in the small pond near where I live. I've seen them in Loch Raven, and I was trying to remember if I'd seen them in the city. I don't think I have, but I've certainly seen their signs around Lake Roland.
Well, I'm in Cockeysville, so that increases.
Oh goodness, you're in Cockeysville. There's beavers all over here. Just Paper Mill Road. You start walking up NCR Trail. There's a bridge and there's a beaver dam right there. And I mean, I swim with them in that creek. I mean, they're just hanging around. We've got pictures of them. Recently, my friends took pictures of them walking on the ice just last week.
Wow. Anyone else?
Any other questions for Dr. Belt tonight?
No, I have a question, and I actually wrote it a while ago, but I'm working with a very small group in downtown Towson. We're trying to stop the building of a 52 apartment 4-story building on a 2-acre steeply forested lot that sits on the headwaters of Herring Run. I heard you mention Herring Run several times. We cannot get Blue Water Baltimore interested in it. We cannot get the county interested in it. They just think it's fine to develop this. This is the only green space in this community, the 2.5 acres. And they think it's fine to put this big building there. And it's, as I said, when it's a very steep slope, and at the bottom is the headwaters to the Herring Run. So I'm desperate for help. If anyone can suggest anything. You talk about daylighting and all that, and it goes under the road and disappears. until it comes out by Radabah Park, if you know where that is, and then reappears briefly at Towson High School and Stoneleigh, and then goes on down into the city. But this is where it all begins, and we can't get any traction. So before it gets even worse, the county and the city have spent fortunes on stopping flooding, but to build at the headwaters seems like not the smartest idea.
Well,
So
yeah.
if anybody has any ideas, I surely would welcome them.
Okay. And your name again was?
Nancy Horst, Horst.
Can you guys hear me?
Is this part of a stream that's right there at Towson University?
No,
Okay.
that's Towson Run. That goes into Lake Roland. This
Okay.
goes south. This is part of Herring Run. You mentioned it about 4 times in your talk,
Okay, yeah.
but this is where it begins.
Creation? Litchfield,
I'm
Can
sorry.
you hear me?
near the that park, it's a Litchfield Avenue, I think, and they've done a stream restoration there.
No, this is in the middle of downtown Towson
Okay, wow.
on Pennsylvania Avenue, East Pennsylvania Avenue to be specific,
Okay.
right next to the Elks Lodge.
Can you hear me?
Yeah, I can hear.
Yes, but
Okay.
just a second.
Yeah, hey, this is Kathy. And in regards to those comments, somebody put it in the chat and I'll agree with them. Contact the Chesapeake Bay Foundation. You could also reach out honestly to DNR. And if worse comes to worse, start contacting the Sierra Club or one of those groups and see if they can help you, because to me, that just sounds like not a good deal. And it not just from a, gee, I don't like the idea, but Towson has had some flooding problems and other things like that with building the malls and everything. I would start like just slamming Chesapeake Bay Foundation and the Sierra Club and let them try and take on and help you with that, is my personal recommendation. Also, DNR may be able to, but I'd hit the NGOs first.
Well, we've contacted Sierra Club. Somehow it seems like political poison. So Baltimore County's Department of Public Works should be all over this, but they won't touch it.
Hey, Nancy, do you want
The
to,
project was given a waiver by the Department of Public Works it had been ownership since 72. It's been in the Mangionis own it, and they were never able to build because there was wetlands on there. That was a stream, and suddenly that all went away. And now we just, it's like a runaway horse.
Nancy, if you want to put your contact information in the chat box, I
Okay.
can also get you in contact with Ken after the show. But are there
Okay.
any other questions to Ken regarding urban stream restoration? All right. We'll put that Nancy.
If anyone has any questions, feel free to email me. It's belt@umbc.edu.
Belt@UMBC. You want to can you type that in there?
Yeah.
Can you type your email in there so folks can get in touch with you? There were a lot of folks that I think are interested. They have streams that they're looking for consultations. I'm not sure where you go. You may have a list of folks that they can get in touch with to have them come out and take a look at their streams, which I think would be great since you're in that field.
And I love getting out into the field.
Great. Thank you, Ken. Thank you, everybody, for coming. As always, we want you to come back and learn with us. Next week is amazing antlers, so don't miss that. That's going to be a wonderful presentation. And I hope everybody stays well, stays safe, and stays curious. Take care, and we'll see you soon. Bye-bye. Thanks, Ken.
Thank you. Thank you all.